Okay, so we're recording. So today we're going to talk about developing connected Windows Store apps with the Windows Azure mobile services. This is an overview session. It's level 200, as I mentioned earlier, but for the people watching the recording, there's a couple more in-depth sessions, and I'll show you what the names of those are. They'll be available up online on Channel 9 with this recorded content as well. So my name's Nick Harris. I'm a senior technical evangelist. I work and live in Microsoft Redmond. Live in the area, not in Microsoft, although it feels like that sometimes. I originally come from Australia. I've been here for about 2 years, and I've got to say I do miss the sunshine. So let me next this. On the agenda today, we'll cover what is Windows Azure Mobile Services. We'll look at its data capability. We'll look at push notifications to Windows Store apps. We'll look at auth. We'll probably do a Twitter auth demo. We'll look at the scheduler functionality, which allows you to run scripts on a time basis. We'll look at diagnostics and scale out. So how many here actually read anything more than the title, i.e. the abstract, for today's session? Okay. So that says we're doing Windows Phone at the end, in terms of we're going to point the same Windows Phone solution at the same mobile services backend as the Windows Store app we built. So if I forget to do that, just remind me at the end. I'll put a note here so I remember Windows Phone. Okay. So what is Windows Azure Mobile Services? So essentially it's a powerful turnkey backend solution for your mobile apps. And we provide it within Windows Azure. It's available within the Windows Azure portal. We'll be in there a lot today. Now, what it does is it provides essentially auth capabilities, structured storage, push notifications, server-side scripting for your mobile apps. So what we do is, out of the box, we provide a number of client SDKs for your devices. So if you focus on the left-hand side here, connected apps, we've got a client SDK for Windows Store, iOS, Android, Windows Phone, and also HTML, JS apps. If you're doing apps, perhaps, a website that perhaps wants to use the same mobile services backend, or say an Apache Cordova application or anything like that. They're all supported. What the purpose of that SDK is to do is to make it really easy for you to utilize a cloud backend. And in this case, it's a mobile service. So it's a nice abstraction on top of HTTP client, essentially. Now, storage of data in the cloud, what happens is whenever you're persisting data up to your mobile service, and we'll do this today, that data is actually stored within a Windows Azure SQL database. So there's a relational SQL DB there, but you actually, as a developer, you'll never actually have to go and touch the schema or write T-SQL unless you really want to. So that's part of the turnkey portion of the solution. You can interact with table and blob storage from your mobile service via server-side scripts, and I'll point out the module you can use to do that. But out of the box, it will always persist to SQL unless you redirect it to write to table storage or blob storage or whatnot. User auth, out of the box, we support Facebook, Twitter, Microsoft, and Google as identity providers. We'll do Twitter. It's quite a simple process and takes away a lot of the pain normally associated with implementing authentication flows. And push notifications are the cool things that light up your start screen. So as far as Windows is concerned, was that me? Okay, I'll stay over here. So push notifications if you want to send live tiles or toasts to your Windows Phone devices. APNS and GCM are also supported if you're developing for Android or iOS-based devices. So just to show the supported platforms, we are very open, and we do provide rich client experiences for not only our own products, but also iOS and Android. So I think the best place to start is a quick getting started demo here. So let me cut across to my dev machine. All right. Zoom in a bit. Is that good for you guys up the back? All right, so this is the Windows Azure portal. It's available at manage.windowsazure.com, or if you're at windowsazure.com, you can simply sign in through the portal option here. So I've already done that, And what we're going to do is we're selecting mobile service. We're going to create a new mobile service. So I select new, compute, mobile service, create. And now we'll provide essentially a unique subdomain for this mobile service. So this is just a name for it. Can I get some suggestions from the very lively and awake audience at this time of the morning? What would you like to call this? Anything special? Everyone's asleep? That's a good one. Except for one guy. Okay, everyone is asleep. Okay, so it is unique, so no one else has taken that, apparently. So what this is doing is, this is defining our web endpoint for our client apps to hit. And we need a database to store that data that we're talking about in. So we've got two options. We can use an existing SQL database. So that's good if you want to have a sort of multi-tenant DB with multiple mobile services pointing at it. Or you can create a brand new SQL database if you want to partition out that data all on its own. You can select a region where you want it deployed. Currently, mobile services is in preview, but we're in these data centers, 2 in the US, 1 in Europe, and 1 in East Asia. As we eventually come out of preview, you'll see that will be across all the data centers that you see Windows Azure within today. So I'll just hit East US. It's going to provide a name _DB for our DB, and I can choose a server here. So I'll choose that database to be deployed in the same region as my web tier. So I'm choosing East US, and now I can simply provide a password and save. Okay, I forgot my credentials, apparently. Let me try that one more time. Everyone is asleep. There we go. New East US. Okay, it's all right for the purpose of the day. Thank you, though. I would fail a code review. Let's check my password. That looks pretty good. Hopefully correct this time. Great. Okay, so what's happening now is it's going off and it's provisioning that web tier, and it's also provisioning a new SQL DB in that East US region. How did I spell it? I'll sleep. Okay. I'll leave. Okay. Okay. Sorry about that's very interesting. Okay. So this provisions, it takes about 30 seconds. Now, as I said, it's provisioning that SQL DB. It's provisioning our web tier. And once this is provisioned, we can then start wiring up a client application to it. And there we go. It's already done. So just to show that this is live, I can click on this, and you'll see that this is a mobile service up and running. So how do we get started with this? This is a getting started demo. So clicking into the mobile service from our dashboard here, these are some others that I have for demos tomorrow. But we've got everyone is asleep, and across here are all the options we'll go through today. But this quick start, this is the quick start tab. So if I select this, this is the quick start. We can choose a platform. Now this provides nice little snippets for getting started with your client applications. You can see we've got ones for Windows Store, Windows Phone, iOS, Android, HTML, and JS. We're going to work predominantly with Windows Store today. We'll point a Windows Phone version at this later on. So selecting Windows Store, we've got two options. We can create a new Windows Store app. So in this case, it's got a simple workflow. Or we can connect in an existing application. So if you have an app you're already developing and it's perhaps disconnected and you want to enrich it and share data between your users, you can simply come in and connect it, and there's some snippets here for doing that. We'll look at the code that this actually has here as part of going through the quick start. So let's do the create a new Windows Store app. I've already got Visual Studio installed. The next step is to create a simple table. So this is a shortcut to the data tab up here. So if I select data, what that's actually done is it's simply gone and created a new table. We'll delve into that in a little bit. And the last step we really need to do now in this quick start demo is to simply download the sample application. So I'm going to save this sample app, which comes out of the box for you. Let me come up and put it in a folder to clean up later. Let's extract this. Okay. Sounds like a train. There we go. So now this is a sample application. Now you'll note here by default it's come down and these references are broken. But what these are actually for, these are dependencies for the mobile services client. So this solution has the mobile services client NuGet package installed, which you could easily go and add by, say, manage NuGet packages, and then just search for Windows Azure Mobile Services. Now with NuGet package restore, that means we can restore these packages. And if I do a build, should go and pull them in for me. There we go. So now it's gone and pulled them down, and now we're using it. NuGet package restore is just a good way to keep the NuGets out of being checked into source control, and in this case, just minimizing the download size. So with this, we're now ready to start this application. So let's have a look at what it does. So this is a simple to-do application out of the box. Its purpose is to demo the basic data service or the CRUD operations that are available. So let me go and show you here. So we can go and say, let's insert a to-do item, and let's say, hello world. Hit save. Nick is awake. Are you? All right, so that's 2 items. Now, while I've gone and hit save, what's actually happened is that data has actually been taken and pushed up to my mobile service and persisted within a SQL DB. So let me show you what that looks like, and then we'll go back and look at the code that's utilized to do that. So let's select data. We click into to-do item here. You can see there's our hello world, and there is Nick's awake, are you? So that's going up. Let's look at the code that's used here. I'm just going to drop this out of debug mode. So the first thing that we had was that mobile services NuGet. The next thing that we've got here is a reference to the mobile services client. Is the font size okay up the back? Yep. Okay. So this mobile services client comes down as part of the NuGet, and essentially this is your client proxy to that mobile service. You can see that it takes 2 parameters when you're newing it up. The first one is the actual subdomain of your mobile service, and the second one is the application key. Now the application key is also available within the portal. If we come back up and we select the dashboard, you can see that we've got our keys here. So that download that we've got is simply gone and dropped in that endpoint and the key for us, and it's got some code. So let's have a look at how we're doing the CRUD operations on that. So if we drop along and go into the back of the main page here, we've got a few things. The first thing that we need is a to-do entity or class that's utilized to represent those to-do items that we're adding and that are being persisted up within our mobile service. So in this case, you can see it's to-do item. The class name matches the name of the DB. You could use data contract and set the name property on that if your DBAs say, like all tables to be prefixed with TBL. So you could do that if you wanted to. In this case, we won't. But the matching is based on name. And it's got an ID, so that's a unique identifier for when that's persisted to the DB. Every entity that's persisted to a mobile service requires an ID. And we've got 2 fields, a text field and a complete field. Now, these 2 attributes here are basically saying when we serialize this, we just want to use lowercase c or lowercase t. You could name these properties anything for the purpose of serialization. And again, if your DBA liked everything prefixed with col, you could just do that. And in the back end, as it's inserted, it'll insert it as col. So with that, that's our entity. Now, how do we actually go and store data up there? Well, you can see here we're referencing that static class that we looked at here, mobile service. App.mobileService get table takes a generic to-do item. So this is the type of table we want to work with. And now we've got a handle to that. We can actually go off and use it. So you can see this is the insert action that eventually gets called after you hit save. And what it does is it calls to-do table, insert async, to-do item. And that's as easy as that. It's all asynchronous, so that's why the await's here. So insert 1 line of code. If we want to query our data back, it's simply to-do table.where, pass in a link expression. In this case, send back anything that's not completed. You could go and extend it if you wanted to. So text is equal to blah, so you could do that as well. So it provides a really neat and easy way of querying data back from your mobile service. And if we go to the last item here, to-do table update async, that's how we perform an async insert operation. So an async update, and in this case, it just takes an item you call update. There's also a delete, so we've done insert, query, or read, I should say, update, and there's also delete if you wanted to delete items. But the main thing to really take away is that we've made this client API across all client platforms extremely simple to use. You don't need to know about HTTP clients. You don't need to know about REST semantics and the appropriate uses of your HTTP verbs. It's just a simple method call. So with that, let's cut back to the deck. So let's talk a little bit about the structured storage. So under the hood, all that data is being persisted to a Windows Azure SQL database. Now, we saw when we were provisioning our mobile service, we had the option to go and say use an existing database if we wanted a multi-tenant scenario. Perhaps we have multiple client apps that we're building and we want to minimize our database cost. In that case, what happens if you use an existing DB, mobile services during that provisioning process will go off and provision each mobile service tenant with a unique schema. So, in SQL, how typically by default, your default schema is DBO. Well, in this case, it's prefixed by the actual mobile service subdomain name. If we named our mobile service "Is everyone asleep?", it would be "Is everyone asleep?.todo item" is the name of the table for this. If we provisioned another one with a to-do item, it would be appysay.todo item. So it separates out the data like that. And on top of that, it also goes off and provisions new SQL accounts that only have access to that schema. So it's separating your data out and securing it in a way that each mobile service has its own unique SQL user that's utilized to connect to that DB. So people can't write scripts in one mobile service that calls in and pulls data from another mobile service within the same tenant. To manage the data, there's a number of ways. So some people will say, hey, that's really cool. You were able to send an entity up and not even go and write any SQL to create those properties that were on the table. So if you recall, we created a to-do item table. There were no properties on that. And mobile services determined by inspecting the entity that was passed up what properties should be added or what columns should be added to that table. In some cases, people want control over that more. You'll see some examples in my deeper dive session tomorrow where we deal with geolocation, but you can actually get access to the data. It's not locked away from you as developers. You can manage it in a number of places. You can manage it through the portal, which is where we saw it before. You can manage it through the SQL portal. So there's a SQL portal built into the Windows Azure portal that you can click in if you click Manage on your DBs. Or if you're familiar with SQL Management Studio, most people here SQL Management Studio people. Yep, cool. So basically with Azure SQL DB, you can change the firewall rules to open up an IP or a specific IP range such that you can connect that Azure DB from on-prem. So you can use SQL Management Studio to get at the data. You can write directly against the REST API if you want, or we have some CLI tools used for automation, which I'll be showing in tomorrow's talk as well. Did I miss something? There we go. So let's talk a little bit about the next bit. We've seen data, but if you're building a device-based application that's pushing data up to a service, whether it's mobile services, whether it's web API, you typically want to do something with that data on the server side, right? It may be just a straight CRUD just to insert that data, but typically what's one thing that you guys would do if you've got client applications pushing data up into any type of service? Validate? Good. Yep. So it's there for that specific reason. Validation, implementation of your own business logic. So behind the REST API or hooked into it, you can actually hook in and start writing your own server-side script. One of the other things configurable with server-side script, we talked about how mobile services goes off and determines what columns are required based on the entity that's being passed up. That's called dynamic schema, and you can turn that on or off. So if you have an app that you're developing, it's very useful to have dynamic schema on because you may go and add a column and whatnot, so it will go and take care of that for you. But I'd probably suggest once you release it to production, turn dynamic schema off. in case you have people trying to attack your service for whatever reason. Ability to author server-side logic that intercepts CRUD. So that's what server script actually is, and we'll do a demo of that. And this server script or REST API provides a rich querying capability, which we already demonstrated. Within your server scripts, it's actually written within JavaScript. It executes within Node. So we've got a number of Node modules available, as well as some modules here that we've wrapped to make it very easy, essentially, to work in that code behind. So we've got an MS SQL object if you want to write pure SQL statements. This is amazing, isn't it? I feel like there's going to be a train bust through and I'm going to have to dive off the podium and do a ninja flip or something. But MySQL allows you to execute SQL. The request object allows you to execute HTTP. So if you want to actually call out to some third-party service as part of your business process, perhaps to submit an order to a wholesaler or something like that, you've got access to HTTP within the server-side script. We've got a console object for diagnostics, push.star. That's a namespace we'll see today. That's used for essentially sending push notifications from all those client platforms that we saw before, being WNS, MPNS, APNS, and GCM. XML to JS is useful if you want to go and, say, read RSS feeds. Provides a nice, easy way to parse XML into basically an object in Java. Status codes, we'll see an example of that. Windows Azure Node SDK, so you can require Azure in your backend, and that's how you get started if you want to start rerouting your traffic that's going to SQL, say, to reroute it to Windows Azure table storage if that's something you'd like to do. And we've got a number of Windows Azure Store partners. So the Windows Azure Store is an option in the portal. So if you want to be able to send email or text messages, SendGrid and Twilio are available. So as part of your process, if someone inserts something, it may send off an email for approval or email out an order or something like that. And Pusher is basically a socket-based solution for sending push events out via the Pusher service, which clients can listen to. And we may see an example of that in my demos tomorrow. Here's an example of the MS SQL query. So some people may use this to say, I want to execute a stored procedure for whatever reason. So you can say execute stored procedure on success. In this case, success takes a function callback, and you just provide whatever script you want to run in that. I'm showing this one here specifically because we won't see MS SQL. We'll see the tables object today, which is a simpler way, a little bit cleaner because you're not executing direct SQL. Okay, so let's do a quick demo of server scripts. All right, so let's jump back to our portal. Going to click into the Data tab, select to-do item. So this is our table. There's our data. If we go into script here, this is where we can actually go and write that script. Now you can see you can hook into any of these operations, insert, read, update, delete, or whatnot. We're going to deal with insert. Let's do some simple validation suggested by the gentleman earlier. Now the parameters, item, that's the item being passed up to be persisted. User, that's the user if they're authenticated. There's some properties on that we'll talk about later. And request essentially gives you access to say things like request.respond if you want to write to the response stream, or request.execute if you just want that operation, in this case the insert, to be executed. So let's have a look at some validation. So we can say if item.text, so where's the text value coming from? Well, that's simply the text property on our item that we're passing up. We can say length. So we'll say if length is less than 5, let's say request.respond, and we can say something here like status codes.bad request. We can say text is too short. And if it's not too short, we want to insert it. We'll say Control A. Let me use, that's the wrong one. Fiddler. Control Alt F. There we go. So that's simply it. If it's too short, send back a bad request and don't insert it. So we're not calling request execute. If it is long enough, we're going to say execute. Now, one helpful tip I'll show you guys is this help bar. This help bar has samples of how you can do a lot of things. Validate data, for instance, is one we're somewhat doing here. But it's a good place as a simple reminder if you wanted to see how to do some things if you're just getting started. The full API of all the, basically all of these objects you see here and all those modules we talked about is documented on windowsazure.com. I'll show you where that is with a link towards the end of the session. So let's save this. So that script we've just edited in place and saved it. And then now that's actually live within the portal. There's no need to go off and say publish your web API and that kind of thing. Your script is just live, ready to run. So if we enter, I said less than 5, right? So if we enter 5, that should fail. I said less than 5. My bad. It's early. You got people, you're awake. It's amazing. So there's less than 5. And you can see that in the error message there, we've got text is too short. So that's a mobile service invalid operation exception. So that's something that you could handle on the client side to simply say, put a try catch around it, and if that validation comes back, then you can surface that up to the UI in a much nicer fashion than having the application actually break like that. So let's jump back to the deck. So that's service script. Let's look at push notifications here. Who's actually done anything with push notifications before? One person? On what platform, out of interest? Okay. And anyone else? Platform? Apple. Okay. So they're all supported. The basic flow for any push notification system is somewhat, 90% the same. There's some quirks around them. I'm going to show you the Windows 8 one here. And essentially, push notifications on Windows 8 allow you to do things like send live tile updates here. I probably should have... Okay, I've disabled my photos tile. Good. So push notifications allow you to send updates to things like tiles. So you'll see that there's tiles here. We've got wide tiles. We've got tiles with images. We've got tiles with different text. Got tiles with like the store app there where I've got 15 updates. That's called a badge. So we've got tiles, we've got badges, and we've also got what we call on Windows 8 toast. So toast is like the little letterbox thing that sort of pops up similar to when you get an email. And push notifications are a way to control this. And why they're important to your applications, particularly on Microsoft platforms like Windows Phone and Windows Store apps, is because this is essentially the gateway to your application. So the whole thing of static icons with no live, up-to-date sort of information is basically we're moving away from that. And what this is doing is it's providing the user something of interest to them that's obviously associated with your application. It's not a place for sending advertisements and that kind of thing. It's a way to draw users back to your application. So if you're providing relevant and up-to-date information, they're going to return to your applications. And push notifications are a way you can do this. And this is going to be a quick 101 of how the actual flow works. Everything in blue are things which us as developers, we need to be concerned about and implement ourselves. Everything in green is provided out of the box for you. It's a service, and you only need to understand how your components in blue call into the APIs that are exposed by the bits in green. So on the left we have our Windows app, Windows Store app, and the first step that it needs to do is to call the WinRT API and request a channel. Now, channel is a unique identifier that allows you to send a push notification to that application, be it a toast or to update that specific tile of that app. What happens behind the scenes is on Windows, the notification client platform will call what's called the Windows Push Notifications Service. The abbreviation is actually WNS. Someone saved people 25% of text writing when you're abbreviating it there by dropping the P. But in any case, that will go and call the Windows Push Notification Service, and it will return a channel and surfaces it back to the app. All right. So once you get that channel, you push it up to your mobile service. because your mobile service will need to know what's the channel that I need to send a notification to. If I've got a weather system or a weather application and I want to send updates about perhaps a change in weather forecast, maybe there's going to be a snowstorm or something like that, the mobile service needs that channel to be able to direct a notification to that user. So we register the channel with our cloud service and we persist that until a point in time that we need it. Let's say our mobile service is monitoring in a scheduled job some Bureau of Meteorology, and it determines that, hey, this is a big thing that Nick's interested in. What it needs to do is it needs to authenticate against WNS and then push a notification directed at that channel via WNS such that I receive the update. And with that, WNS will take care of pushing that across to the notification client platform and will take care of surfacing that as a nice tile for you. Now, to do this with mobile services, what we've got is we integrate with WNS to provide toast tile badge and raw notifications. I forgot to mention that before. Raw is just a way for you to send data packets to your application if it's running in the foreground or if you have a background task running. It's sort of useful if you just want to sort of transfer information down to the device using a push-based mechanism rather than a polling-based mechanism for your app. So you can sort of do updates in the background to whatever data sets are on there. In any case, the Windows Azure portal captures your WNS client and secret. So these client and secrets are what are used to authenticate against WNS in that third step. And then within server script, we can use push.wns. If you're using Apple, like the gentleman mentioned he was using over there, we have push.apns for Apple-based systems. We also have MPNS if you're building Windows Phone apps, and we've also got GCM if you're building Android apps in that namespace. And essentially what it does, it provides a clean and easy object model for you to compose your notifications. So if you've ever had to implement this before without any nice abstraction on top of it, it's actually quite a bit of effort to go and implement, an OAuth handshake, get a token back, stuff that in the auth header, and then, compose a notification, which is an XML payload, and then post that to WNS. This will turn all of that into a little bit of configuration and one line of code. So it's really quite powerful. It's going to save you a lot of development effort. So I think we're up to a push demo. So let's continue with this, and we'll do a toast perhaps, and we'll do a tile a bit later on. So let me carry on with this same app that we've got here. So the first thing we needed to do, there were 3 steps: request a channel, register the channel, and then authenticate and push. But if you recall, we do need to configure those credentials for our application. So let's start with the configuration. So the first thing we need to do is to register this application as a Windows Store app. And that's going to go and grab our client package name. And we can do that using right-click on the project, store, associate app with store. This brings up a nice simple wizard that's going to connect to the store for us. So I can say Azure sign in to my store account. That's going to get a bunch of apps that are already created in store. If you haven't reserved a name, you can just reserve a name through this link here. We'll actually need this in a little bit, so let me just load that. I think I'm hinting to myself that this is the one I should use today. So I've pre-created one, nothing special. Just hit next. And now what this is going to do is it's going to pull down this configuration and put it into my package app manifest. Now the key thing here really is the publisher ID and the package name. That forms the client component of the OAuth flow that's going on with WNS. So these are, we could say, our client secrets. Now the next thing that we needed to do was to configure our service tier. Now on our service tier, to send push notifications, we've got this push tab. And you'll see that we've got Windows application credentials here if you're using WNS. If you're using APNS, you can go and upload your certificate here, and you can also edit a feedback script which is executed in part of the process flow that APNS has. More on that in the dedicated iOS and Android talks Chris is doing tomorrow morning at the same time. And GCM, you've got the app key. So we're going to provide the client secret and package SID here for WNS. To do that, we use the portal. So that's why I clicked on the reserve app name so we can see. We don't want to reserve a new app name. We'll just go in and select TechEd Tuesday, hit edit. And now within here, we've got services, add push notifications, authenticate users. So I select services, and then we're using a WNS solution. So we're going to click to this. Our identify our client app was all done through that client workflow we did in the wizard. So let's get the credentials to authenticate our service. We've got a client secret here. So I'm just going to drop this into the portal in the client secret tab. There we go. And a package SID. Let's drop that in there. Sort of wish that they were reversed in the same order. In any case, it will give you an error if something's wrong with one of these, right? So there's some validation there. And we hit save. So that's essentially our configuration for the auth flow to work. Under the hood, we're going to take care of all the rest for you. So let's get started with the first step now, which was essentially to request a channel. So we can do that on our client application here. I'm going to drop it in the app XAML CS. I've prepared some snippets to speed this up a little bit. So let's say request channel. And we'll walk through this code. So let me resolve the references here first. We've got async operations. So the first statement here is really to request that channel. So that was the first line we saw with our app calling into the client push notification manager. So push notification channel manager is part of the Windows networking namespace. And there's this extremely long method name here. In case you didn't see it, there it is, if you wanted to note that down. And you'll actually... Does anyone know what the longest method name, I think, in WinRT is? Anyone want to take a guess? Okay, it's for secondary tiles. So secondary is slightly longer than primary. So if you have a weather application like I've got here, when you pin multiple tiles, you can request a channel for each of those so you can target individual notifications to it. Bit of useful information. But in any case, we request the channel. So I got my channel here. And then I'm going to use an entity that I want to be persisted, because the entity that comes back here has a lot of stuff that I may not actually want. It's called a push notification channel is the type of class. It's got a lot of information that I don't necessarily need in my service. So I'm going to drop in a little class here. And, you know, if you're doing this in real life, you'd say add new class. I'm just keeping it all in one file to stop jumping around. But essentially, this channel has an ID, a URI, and an expiry. So let's have a look at how we populate this. So this is going to be our DTO, or data transfer object. I'm doing some jiggery here around setting the ID, and we'll walk through that. But the key thing to understand is we've got the URI, that's our channel URI to direct our notification at. We've got an expiry. So channels do expire. That's why I'm requesting a channel every time the app launches and updating it within my service. So in the first case, when we go through this workflow, essentially what's going to be hit is to call get table, in this case channel, not to-do item, insert async, that channel DTO object. Now, the way I determine if it's been inserted before is once I insert it, this channel DTO actually on the mobile services server side assigns the ID because it's a seeded identity int-based column, and that's actually all pulled back out into the client after you hit insert. So an ID will be assigned here in this case, and I save it in my local settings. So the second time this application launches, what actually happens is I say, well, to set the ID on this object, if it exists in local settings, then we're going to use that. Else, basically, it's somewhat casting it as a nullable int. So if nothing's in there, we're just going to get null. And in that case, channel ID is null, do the insert, otherwise we're doing an update. And that's our request channel and register it step done. So the next step we had to do was to take those channels and compose our push notification. So let's have a look at how we do that. So I'm going to come here. I'm going to go to the Data tab. Now, does anyone know what's missing, perhaps? We were trying to write to a channel table, but we don't have a channel table here. Now, the dynamic schema will deal with going and adding columns to your tables, but it's not going to create a new table altogether for you. So in this case, what we do is we create an empty channel table. We've got some permissions here. We'll look at that when we get to the auth piece. And this matches the name of our entity that we're passing up. And let me show you here so we can see the dynamic schema in action. If I select columns, there's only an ID column. When that entity passes up, it's going to go and add the channels for us. Excuse me. So let's run that so we can see the channel. It's a lot of steps in this, and takes a while to get through them all. So we've done step 1 and step 2. Our application is launched. Let me come in back to the portal now, and we can refresh this. We should see that now we've got our channel. You can see the columns have been added. We've got our URI and expiry. So now this is something we can work with within our service. So what I'd like to do here is I'd like to send a toast notification on insert in this case. To do that, I've actually gone off and created a handy little snippet to save me typing all this. And let's walk through what this is doing. It's the same insert operation. In this case, we call request.execute. Now, this is a success callback. So once it's on success, we execute this function. This function responds to the client, so the client can go on and do its thing. And then we send a notification. And as part of that notification payload, I'm passing the item in such that I can perhaps grab the text that's inserted and send it back to the user. So in the send notification function here, I use the tables object, which we talked about earlier, and I simply say get table channel. Now from here, I can say channel table dot read. Now the read operation is going to pass back an array of channels. And then I simply say, for each of those channels, I want you to execute this function. This function is going to take the channel, which is the current element in the array that we're within the for each, and we're going to compose a push notification. So push.wns, send toast image and text, is directed at the channel URI that we talked about, being the unique channel for the application. And in this case, toast image text is a template, and it expects an image and 2 text items. Let me show you this for a second, windowsazure.com. Let's go to documentation, services. Where are you? Mobile services, developer centers. We'll go through developer centers. Is it there? There it is. Yeah, mobile services. So this is the mobile services developer center. And handy thing if you're composing push notifications is to look at this reference documentation here. And if you come down, there will be mobile services scripts, and then this has taken me to where I didn't expect to go. Let me try this again. That's in how-to. Let's go to REST API. They've just updated the site, so there's a few things that are a little bit different. This is where I was trying to get you to. So push.wns we're using in this case. And you can see that there's a number of overloads here, and it tells you how you can go and compose each of these different notifications. So we're composing a toast image text, I think it was 02 or 03, and you can see here that it'll redirect you out, and you can go and look at the different template types and choose one that's appropriate for your application. In any case, we come back, so we're going to send an image. This is a public image in blob storage of my colleague, Nate. We're going to pass the item text back to the user, and we're going to add some other random text for the second line of this particular template type. So now that's saved, this is actually live. So if we, our app is still running, if we go and say, Nate is enjoying this too much, and hit save, That's going to go and insert it, and you can see here that my colleague getting makeup for our live stream session at Build last time has a big smile on his face. Perhaps a little bit too much than it should be. But that's an example of sending a toast notification, and you can see that the text from my item is there as well. So 15 minutes or so, definitely a lot faster to do it like this than going and implementing directly against the API that WNS provides, because this is a lot more simple. The other one took me several days to figure out initially, and then building a .NET wrapper around that took about a week. In any case, so that's a toast notification. What do you guys think? Easy? Everyone waking up or falling back to sleep again? I'll try to liven it up by falling off the back of the stage or something. Yeah, watch out for the train. Seems like they've finished whatever work that was. So let's talk about auth here. So from the auth perspective, out of the box, mobile services supports Microsoft account, Twitter, Facebook, and Google. On those tables that we're creating, by default, when we create them, they're locked down by application key. So what that means is the consuming client needs to call that service with the application key that we saw within the portal, and that was passed into the mobile services client. In terms of levels of permissions we have on each of those CRUD operations, you can say it's open to everyone. You don't need to be authenticated. Perhaps useful if you want to expose some data set that you want anyone to be able to read, any application developer that is. The default is anyone with the application key. And then there's 2 levels above that, only authenticated users. So that's if you're using one of these identity providers. And only scripts and admins if you want it to be only your server-side script that can execute this, or anyone with the master key, which was the bottom of the 2 keys we saw when we clicked on Manage Keys in the dashboard. So you could imagine using the master key perhaps in some kind of script or app that you've done to automate processes that you perhaps run or execute as part of a build process or anything else like that. Now, that deals with authentication. You may want to authorize users. So within the mobile services portal, we saw that there was a user object. That user object has properties on it like user.level, so you can see what level they're authenticated as, and user.userid. So you can build out policies on top of this to say, for instance, as part of the sign-on process, you may assign everyone with user.userid a particular role, and you may go in and change that to say Nick is, an elevated role because he is doing okay with this session so far. I think you're awake. Most people. And in any case, you can use this to go and do that. We'll see a little example of doing this to filter data back. So I think that brings us to adding auth. So let's cut to that. Close this guy. Oh, excuse me. I'm breathing into my microphone. We'll come to the Identity tab. Now, each of those identity providers, it's going to load here. Any second, I can guarantee it. Not sure what's going on there. There we go. Just a little bit slow. So if we're configuring a Microsoft account, we do it here, Facebook, there, Twitter, and Google. I'm going to do Twitter today. And in essence, the workflow is the same for any of these identity providers. You'll need to create an application and provide a URL that redirects to, which is your mobile service. So let's do Twitter. Let me go here. So at dev.twitter.com, you can sign in. Seems the network's starting to get a bit slower. Everyone's reading the news or something. Okay. So once you sign in, you can go to My Applications, and you can create an app by hitting Create New Application. And we'll call this application everyone is sleeping. Description, everyone is sleeping. Website, this doesn't matter so much. What does matter to get right for your auth flow to work is the callback URL. Now the callback URL needs to be your mobile service. So you can grab that. An easy way to find it again, if you don't remember the full thing, is to go to the dashboard. Come back, we drop this in. Scroll down, we read this, and then we try and get the capture control right. I always wonder where they get these words from. Stir. There we go. Did I really? Oh no, that's just my font size because I got the zoom set here. I think if I drop this back, it'll be right. I'm pretty sure it's a Y. Seems like they're sort of clipping that a little bit with whatever CSS they're doing. Yeah, thank you, though. Good, you're paying attention. I wish I had some prizes. Let's zoom this out again. Hit create. And that's our Twitter app created. Now, this provides two keys back. Consumer key, which goes back in the identity tab. Consumer key and consumer secret. Now, with that, our actual configuration for auth is done for the server side, but we want to restrict that table permission. So if we go back to data and we say, perhaps our to-do-item table, let's change the permissions that everyone inserting to this is now no longer anyone with the application key, but we want them to be an authenticated user. So this will now allow them to authenticate with any of the identity providers that have been configured in the Identity Provider tab. So if I run this now without actually logging in on the client, it will throw an unauthorized exception. So there's our unauthorized. So what we really need is to log in now with Twitter. And what we've provided is a nice, as part of this client SDK, is a nice abstraction on top of the web authentication broker, which is available within Windows Store apps. And we can say, await, app.mobile service, login async, and then here we can provide our mobile service authentication provider. In this case, we're using Twitter. Let me show you that here you have the other options that are configurable within the portal. So if you wanted to provide perhaps a login that had each of those, it's as simple as just providing a screen. When you click on button 1, it goes to Twitter, one goes to Microsoft, one goes to Google. So if you want to expose all of those identity providers in an app, it's certainly possible and very easy to do so. But what I really want to point out is like the power and ease of configuration of this auth flow. We're actually done. Create the app, configure your service, restrict your table. We saw that it was restricted now, and then drop in this line to actually provide your login. Probably put that in the wrong place, did I? Let's see, it's trying to read my items before logging in. There we go. I put it in the refresh button as opposed to here. So I'm just hooking into this bit to provide a login. You could do it in another part of the page lifecycle, but in this case I'm just doing it here. It tried to call refresh to-do items, which was doing a query, and of course my login was in the in the actual save button click or something like that before. So let's run that again. And we'll see now that we'll be presented with our login before we actually execute any of our queries. So it's just a matter of, depending on how your application's implemented, calling login before you do anything with your data tier or provide appropriate handling to pop up the login screen. So you can see this is the everyone is sleeping up. They say don't get. All right. Don't forget evals. Okay, lame auth joke. Okay, hit authorize app, that time with my real password. And now we're authorized, and we can actually start doing things like adding data. So that's auth. Quite straightforward, right? What do you guys think? Cool? It is a lot easier. Question?
Our company has its own SSO provider.
Yep. Yep.
You have 4 choices there. How would
Yep.
which choice do you have?
Yeah, so actually I'm doing that in my session tomorrow at 3:15-ish, I think. But basically the client API for mobile services, it's mobileservice.currentUser. You can authenticate against that SSO using Web Authentication Broker, which is provided in this case as part of the API here in Windows Store Apps. You get a token back, and then you can utilize that token to essentially sign on to that application. But that token does need to be in a particular format, and we'll sort of go into that in tomorrow's session. So it's more of the 300 level than 200 here. But the key point to note is we've taken that extensibility into consideration, and what we'll be doing in that case is caching some credentials. We'll also be doing custom Facebook auth, and we'll also be using Windows Azure AD. So those demonstrations will certainly apply to your scenario. But it's doable. You do have to do a little bit more work because it's not out of the box, but we've catered to extensibility. So that was auth in minutes. Let's talk about the next piece here, which is the scheduler. How do you guys say it here? Do you say scheduler or scheduler? Scheduler, okay, yeah. My colleagues at work have always been, you're saying it wrong. The guy that was getting makeup, he's pretty credible. But I have to share an office with him, so we have a lot of fun. But in any case, the scheduler executes scripts on a schedule. Now, what we've got here is 2 real options for running a scheduler. Execute on a scheduler, which can be by minutes, hours, days, or months. We'll see this in the portal. We can execute them on demand as well. So if it's something that you want to only run at some point in time that you deem it necessary, you can do it like that as well. Examples of where you'd use this. So we've been looking at server script from the perspective of let's go out and add some script which is intercepting a CRUD operation. You can actually go off and in this case do things like periodically purge old data, poll and aggregate data from third-party sites using this. You can process and resize images, and you can also send push notifications for a given time of day. And while I say this, I forgot the most important part of the last demo. So let me flip back. We're going to talk about auth just briefly for a second. Sorry for the jumpiness. So we just saw that auth flow, right? What I'd like to show you here is how you can start filtering your data based on that auth flow. There was a gentleman I was talking to earlier this morning, and I said I'd show this. So in script, when we're talking about auth, recall how we said that there's the user object, and the user object has user ID. Well, what we can do here is we can say item.userid and dynamically add a user ID to the item being inserted in the server script. Dynamic schema will go and add a user ID column, and we can now say user ID properties equal to the authenticated user's ID. I hit save on this, and now when I insert, I'll get a user ID, but perhaps I want to go and filter the returned result set to only those records for the authenticated user. So we can hook into the read query here and say query dot where, and we can say the user ID column of the table matches the currently logged in user ID. And that will simply now, when request execute runs, it's going to filter the results to only those items for the logged in user. So let me run this. Then we'll jump back to scripts. Let me log in. So one question you may have is, why do I have to log in again? The credentials are not cached, and that's something I'll show tomorrow. I almost clicked view my password to make sure it was right that time. It's a bad demo. And you'll see that this is showing no items. That's because in the portal, there was no user ID property until now. Unauthorized. Did I do wrong there? No, the too short one's not running on there. I save everything. Try to log in appropriately. Let me try that again. That's bizarre. Let me see here. Don't tell me I've gone and done something wrong in my demo flow. I should have ignored this. Let's see. Request, tables to item. Why are you giving me unauthorized? Where's my auth header? Yeah, no, it shouldn't be. I'll have to look into that. That shouldn't be happening. I've done something slightly wrong somewhere. So ignore that. I will come back to that in probably tomorrow's session. Apologies. But it should be as simple as that. Let me just check I didn't do any typos in my scripts. That's bashing it. User ID, user ID. That's fine. Logging on Twitter. One last thing, because we need to talk about diagnostics at the end anyhow. See if it's even hitting this. The auth error seems to say that it's not. Check permissions, only authenticated users. So that's good. The read query is working because there's nothing there. How bizarre. Okay, I'll have to look at that. I wonder if it's an actual new bug of some description. So auth before. User ID. Okay. All right, apologies. I should have stuck to forgetting that. In any case, something has to go wrong at some point, right? Let's poll Twitter on a schedule. Okay, so scheduler. Click into the scheduler tab. We can create a schedule here by just simply hitting create. Whoops. Everything's going downhill. Let me show you where that is again. So we're working on everyone is asleep, scheduler, create a scheduled job. This job name is going to say check feeds. Now you can see these are the two options, scheduled or on demand. Most granular that there is on a schedule is 15 minutes, but you can go up to hours, days, months. So we're going to say every 15 minutes. By default, when you create it, it's disabled, and that's so you can go off and author your script without having this stuff executing while you're working on it. So we just click into the script tab. Now I've got a check feeds here. Let's do a run once actually to show you on demand. This is a console log operation or a console warn operation. If we go back to logs, you'll see that there's that warning written in there now. So if we return to scheduler, we'll go into check feeds, script. I'm going to paste in my snippet here, and this snippet is going to poll Twitter and send a tile update. So let's walk through this. The entry point is the same name as the actual scheduled job. It says get updates and notify. In this case, we're using the request object to do HTTP. So we use require request. We call get updates and notify, and we're going to hit the Twitter API. So let's show you what this looks like. Hit open, and you can see that's returning back tweets directed at CloudNick. So that's 2 tweets. So if anyone is on Twitter and you want your face to be shown, given there's no demo fail, we'll see how that can work. You just need to be the most recent tweet at my alias. Now, once we do that request, we can parse the result of that. So you can see that this function is executed after this HTTP request is completed. It's got a body parameter, and that has results within it. If there are results, we're going to iterate through each of those, and a result in this case is a tweet, and we call send notifications and pass in the tweet. Now, similar to before, we call tables.getChannel, get table, and we get the channel table. We read through each of those results. Again, that is a channel result, iterating through them. We have a channel, and now in this case, I'm sending a tile-wide image and text at the channel URI. I'm taking the Twitter profile image and the actual user that tweeted me and the text from their tweet. Now, that is something that can run, say, every 15 minutes and update a live tile. Now, this is using a special sort of tile called tile-wide image, tile-wide small image and text. So it's a wide tile with a small image on it. So it's essentially a tile like this with a little image and some text. So what we need to do in our client app in this case is actually configure it to enable wide tiles. And I forgot to do this before. So if I select this, you come down, select wide tile, and we can provide a default tile here. So this essentially enables this application for wide tiles. You can go to my pictures. You can see there's my colleague Nate, a little bit larger. That's me when I had hair in 2005, and my nieces had been playing with it. And in any case, we need a wide logo. That's 310 by 150. So we'll drop that in. Now, if I run this application, it's going to redeploy it. And as part of that, we should see now we've got this guy here. Let me bring it across. Drop it there. Now we can say we want the larger option of that. So that's our default tile. Now, as part of that, what's gone on is, let me jump back to the portal. I forgot to actually add the wide tile before. When you add the wide tile, it actually deletes the local app settings that we were using to track the current channel. So you'll note now that our little insert update trick isn't working because, in this case, that was cleared because that's a sort of change that will delete local settings and the state within that property bag. So our update has done an insert this time because we changed that critical component of the package manifest. So this is our channel. So essentially we've got a wide tile, and now we've got a scheduled job, and this scheduled job is called check feeds. It'll hit Twitter and then send a tile update. So let me close this. We don't need it running, of course. And let's do run once on demand, because when you enable it, it actually executes on every 15-minute interval. And we probably don't want to wait for 7 minutes. So that is run. If we sit here and wait for our tiles to start popping and peaking, we should see it come in here at some point. You can do it. It's meant to be a random decision of when the tiles pop and peak, so they look more random and your eyes sort of dart around. Oops. This is not fun. Let me add some debug code here. And we'll say success function R for response, say console.log R, and we will add an error function E, see if something's going awry. Maybe the size of someone's Twitter image isn't the appropriate dimensions for the template. So that's another thing to note. These templates, the actual dimensions of these will determine whether things are shown. So if this random image is 2, the dimensions are out of proportion for the little square that it expects, then it won't actually render the notification. Let's do run once on this and see what gets logged. Error in script. Check feeds is not defined. Interesting. Seems like... well, that would do it. So the entry point name has to be the same name as the job. Let's do this. Okay, I think I just run it. Let's do it one more time just in case. Let's check our log. Okay, so that's good. Whoa! Oh my! You do win. Amazing! Sorry for the demo difficulty there. Let's get a round of applause. I'll start with a slow clap. Okay. Thank you. I was sweating there for a second. It helps to be able to spell things right, I guess. So let's talk about closing up. We've got a few minutes, and I'll be available after the session for Q&A. Diagnostics, logging, and scale. Within the portal, we've got a dashboard that you can see the number of APIs, CPU time, and egress out. Scaling your compute instances, I'll show you a demo of that, but basically you can scale up the number of instances you have of that mobile service, and also scale it to a reserved mode VM. So by default, you're running in a free tier. You get 10 mobile services for free. And you can scale out to reserved if you want to have, say, not be in a sort of shared compute mode, but in a mode where you've got your own VM running that mobile service. Logging, we saw some examples of that. That's for sure today. And scaled from the storage perspective, you can actually move a single tenant out to a dedicated DB through the configure options in the portal. And you can obviously scale up that Azure SQL DB to be up to 150 gig. The one thing to note when you scale the tenant to a new DB, basically it's just a reroute of the connection string. You will need to write some T-SQL to pull the data across for that tenant, so don't forget that. So I'll just show you in the last 2 minutes and 13 seconds the scale option in the portal. So like most or all of our services in Azure, we've got this scale option. Now by default, we do get the 10 free mobile services in free mode, which is sort of shared. If we go across to reserved, it does say, hey, this is going to incur a cost. I can opt into that or acknowledge that, and then you can go and scale out your mobile service. And I can go and scale this mobile service to be across 3 instances in reserved mode, and that change actually takes effect within only a short number of seconds, which is there, and that will be done as soon as that screen refreshes. But in those few seconds, it's actually taken this thing from a shared core over to 3 dedicated cores in like 10 seconds. So it's really useful if you're running applications that perhaps need sort of burst compute power. You can just do this, scale it up for the particular event or the time where maybe you're getting a lot of registrations or traffic, depending on the application type, and that's basically it. So with that, let's summarize. I got 56 seconds before I get chopped. We looked at Windows Azure Mobile Services. There's a little glitch in that slide. We looked at structured storage, server-side script for writing your business logic, auth. I do have something to figure out that was going wrong there. Notifications, sending push notifications from multiple client platforms. We looked at the scheduler, logging and diagnostics. That was the console.log. The diagnostics are available in the dashboard, and we also scaled out. So with that, these decks will be made available online. There's some links here. The key thing to remember is just windowsazure.com, go to mobile, and here's the related content. And with that, thank you. I believe that's the end of the recorded session. Thanks. So if anyone has questions, please feel free to ask or come up, whatever you prefer. I'm not sure what the break is between sessions, so if you need to go, by all means. Yes, right. So disconnected as in occasionally disconnected or completely disconnected, like I'm just building a client app? Yeah, right. So do I have a session specifically addressing that? No. The next session that I'll be doing is geospatial, deeper auth. That's the second of the two. Chris is doing a deep dive on iOS and Android. He's like the iOS Android guy. I'm the Windows guy. But yeah, if you're building iOS or Android apps and you really want to see what the client libs look like for that, I'd certainly recommend sitting in on Chris's session. This one's geo, or the second one's geo auth, cleaning up push, like implementing it a bit more properly than what we did today. And can't remember what the other things. It's in the abstract. That's just off of the envelope. Lost it. Hey.
It's possible to integrate this with a service you already have, on-premise solutions with server bus or something like that.
Yeah, you can most definitely integrate this with on-prem stuff in the sense that, say, if you had a service bus locally, you could actually in service script call to inject, say, that to-do item, say, directly into your service bus queue and have, say, a Windows service on-prem chewing through the queue and doing whatever you want with it on-prem. But yes, you can certainly do that if it's publicly visible, that service bus endpoint. So you can also say with the new BizTalk services which were announced, you could say, for instance, push your entity directly into an endpoint for BizTalk. That could do a translation, say, from JSON to XML, chop and change it how you want, and push that into on-prem as well. So, yep, definitely possible. Anything that you can do with HTTP, you can do with mobile services from the script.
This will work with when we're going to move your Active Directory to the cloud too, so it's going to work with that too as well.
Yeah, you can use Windows Azure AD. Today it's not out of the box as one of those identity providers. Certainly feedback we've been hearing, so it's something that we're strongly considering. Tomorrow's demo, we'll have Auth0 here, which is basically an identity provider that does all the configuration for you, like a middleman type thing. So that's certainly worth seeing if you're interested in that specifically, because he's going to demo a Windows Azure AD demo in that. But he'll also talk to how you could implement that yourself if you didn't want to use that particular service.
They did talk about one of the new features with the update is to move everything from, or sync your credentials with Windows Azure.
Yep. Yeah, so certainly through the extensibility in the client API today, you can use Windows Azure AD. Yep.
Also on the channels.
Yep.
The channel table, it has an expiration, so does
Yeah.
it automatically get created after?
No. Yeah, so that's part of what I'll be addressing tomorrow is how do we clean that up? The answer is quite simple. You just delete anything in the scheduler that's expired, so that you're not trying to push that in. Yep, no worries.
Appreciate
Thank
it.
you.
Thank you.
It's not part of the SDKs. The way you create to
Yeah.
communicate between the client and server.
Yep. Yeah, the channel table is not part of the SDK. It's something you need to manage yourself, and best practice with with the Microsoft push providers anyhow. Expiry in Windows Store apps is important. If you try to send to an expired channel, you're not going to get anything, so it's an inefficient use of your compute. And in addition to that, WNS provides back response status codes as to if the device is offline or temporarily disconnected. So you should really handle those responses. That was what I logged up there. Tomorrow I'll be showing how you can do a simple way to say, maybe I'll back off for another hour on this scheduled job, which runs every 15 minutes, to wait until, hey, it's maybe out of that disconnected state. Yeah.
When you send Apple push notifications, you know that you have a limit of like 200 characters in the payload.
Right.
Do you use the same limits?
I believe that I'd need to look at the actual script for the push.apns namespace. You'll just be supplying a string.
Okay.
I don't think we'll be doing any validation. That would be in your feedback script. I think that'll come back, and you'll have to know that there.
Okay. In order to send notifications, you have to use the...
Sorry, just let me grab